Hyperbolas. So, the vertices and the foci. So like I said earlier with ellipses, the first number is always a. So a is going to be 4, and we don't really need b. B squared is 65. To find the vertices, this is centered at 0, 0. And so we look at our chart. I need to flip a page here to look at that personally. You may need to as well. So just flip the page over and look over at hyperbolas. Alright, so x is first, so we look at the first column, and our vertices are at plus and minus a, so that's going to be plus and minus 4, 0. Then to find the foci, we need c, which for hyperbolas, the Pythagorean relation, it's the one we know and love. A squared plus b squared equals c squared. 16 plus 65 equals c squared. That's 81 equals c squared, so c is 9. So our foci are at plus and minus 9, 0. So that's that there. On 18, we are not centered at 0, 0, so find your center first using the super secret opposite society. -2, -4. A is going to be the square root of 225, which is 15. We can find c by doing a squared plus b squared equals c squared. That gives you 625 equals c squared, which means c is 25. Now, since x is first in this problem, and we're looking at centered at hk, our vertices are at h plus or minus a comma k. So we'll do -2 plus or minus a, which is 15, comma k, which is -4. So you actually do -2 plus 15, which is 13, comma -4, and then you do -2 minus 15, which is -17, comma -4. Those are our vertices. Our foci are at h plus or minus c, comma k, so that's -2 plus or minus 25, comma -4, and then actually figure out what those are. So -2 plus 25 is 23, comma -4, and -2 minus 25, -27, comma -4. So there's our answers on that. To graph, we need the center, which is -5, comma -3. We need a and b. And so you go to your center, -5, -3. And you put like a dot. From there we draw a box. We're going to go left and right 5 for a, because that's what's underneath x. So that puts us here and here. We're going to go up and down 3, so that's here and here. Then we're going to draw a box. And then through the corners and center of that box, we draw our asymptotes. I guess the alternative would be for us to find the equation lines for our asymptotes and do that instead, but to me this seems easier, personally. So ignore those extra dashes out there. Since x is first, you have to draw your curve on the left and right side of the box, and we don't have a ton of room on the left side, but your curve looks kind of like a parabola. It heads towards your asymptotes, but never actually touches them. So there's a approximation of our hyperbola. On 20, we have to divide everything by 324 to get it in standard form. And that gives us y squared over 9 minus x squared over 36 equals 1. So we're centered at 0, 0, and a is 3, b is 6, but notice that since a is underneath y, that means we're going to go up and down 3. That's an easy mistake to make. So Start at 0, 0, we go up and down 3. We go left and right 6. Draw your box. Draw your diagonals. Now this time, since y is first, we draw on the top and the bottom of our box. So when x is first, you draw left and right. When y is first, you draw up and down. Or top and bottom, or whatever. Find an equation in standard form for the hyperbola that satisfies the given conditions. So they tell us about the vertices and the foci. And because these are both at plus or minus something, this has to be centered at, at 0, 0. And because the x value is changing, x squared is coming first. So I can at least set up this much of it. Our vertices tell us that a is 4. The foci tells us that c is 10, which means that we can use our Pythagorean relation to find b, or just b squared. We don't even have to actually square root it. 100 minus 16 is 84, so b squared is 84. So underneath x we put a squared, underneath y we put b squared. So our answer is x squared over 16 minus y squared over 84 equals 1. 21. We have a center given to us, which is h and k. The focus, it gives us one of them, not both of them. So we know, for one thing from this, which column to look at. We can either say that 6 is h plus c or h minus c. It doesn't matter as long as you know that the c you end up with, you want to change it to be positive. Vertex of 5, negative 4 means that that could be like h plus a. So from the center, which is 1, our focus is at 6, which means c has to be 5 because that's the difference between those. The vertex is at 5 and the center is at 1, so that means a has to be the difference between those, which is 4. So we can find b because we can do a squared plus b squared equals c squared, and we get b squared equals 9. So because our y value didn't change, that means x comes first. And right. So that's going to be x minus h, so x minus 1 over a, which is 6, or a squared, which is 16, minus y minus k, which is y plus 4, over b squared, which is 9, equals 1. Alright, 23. E equals c over a is for eccentricity. So we first need to find standard form and then find a and c. Well, there's a little dyslexia right there. 8 over 72 can simplify to be 9 on bottom. This one simplifies to be 8 on bottom. So a is 3. And to find c, we do a squared plus b squared equals c squared. So c equals the square root of 17. So e equals square root of 17 over 3. A comet follows the hyperbolic path described by this equation, where x and y are in millions. If the sun, millions of something, who knows? If the sun is the focus of the path, how close to the sun is the vertex of the path? So the sun is right here, and they said that's our focus. And here's what's important for us to know graphically, is that the distance from 0 to our focus is c. The distance from 0 to our vertex is a. So if we can find those two things, we can find what we're really looking for, which is the distance between the vertex and the sun, by subtracting them. So given our equation up here, A is 5, and then we can find B, but we don't need to. We need to find C, which is A squared plus B squared equals C squared, which gives us 42 equals C squared. So C is the square root of 42. So we want to do the square root of 42 minus 5. And our answer is in a decimally sort of situation here, since it's like a real world problem that we typically want to get a decimal. And so I get 1.481, and then this is in millions. I don't know what millions it's in. Could be in it could be 1.481 millions of yardsticks. You know, you never know. It could be something, but it's probably not. So never mind.